Okay, so these were the practice questions you had on the second page of that PDF that I posted. The first one says, number 4, write the full electron configuration for each of the period 3 elements. Now, we didn't talk about that in the last video, so the question is, which way are the periods? Are they the vertical rows or the horizontal rows? And hopefully, from chemistry, you know the periods are the horizontal rows. Groups are the vertical rows. So it's asking you to write the electron configuration for each of the elements in period 3. So the first one is sodium, and we already did that. So its number Z is equal to 11. So it's 1s2, 2s2, 2p6, that makes 10, and then 3s1. Next one is magnesium. Z equals 12. 1s2, 2s2, 2p6, 3s2. Next one is aluminum. Z equals 13. 1s2, 2s2, 2p6, 3s2, 3p1. After aluminum is silicon. Z equals 14. 1s2, 2s2, 2p6, 3s2, 3p2. Phosphorus. Z equals 15. 1s2, 2s2, 2p6, 3s2, 3p4. Hopefully you're, did I miss a number? Maybe it's a 3. Hopefully you're noticing that all you're doing is just adding one more. Nothing in the beginning changes. So 1s2, 2s2, 2p6, 3s2. This time it really is 3p4. And maybe it's not phosphorus, maybe it's sulfur. Then chlorine. 17, 1s2, 2s2, 2p6, 3s2, 3p5. And then the last one in that row is argon, 18. 1s2, 2s2, 2p6, 3s2, 3p6. Okay? And so now the period is finished because the 3p is full. All right, question number 5 says, write the full electron configuration for each of the halogens. Describe how the halogen configurations are similar. Does this similarity apply to other families? So the halogens, these guys are the noble gases. These guys are the halogens. And so, number 5, fluorine. And fluorine's Z is equal to 9. So 1s2, 2s2, that's 4. We need 5 more, 2p5. The next one is chlorine, which we did just above, 17. 1s2, 2s2, 2p6, 3s2, 3p5. Then we have bromine, which is, if I could only see the number, 35. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Now I have to add up, and then it should be 4p5, 10, 20, 35, yeah. After bromine is iodine. I and it said equals 53. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and this should be 5p5. 10, so what we were at, so 10, 20, 32, 38, 40, 50, 55. Is that what I was supposed to be? Do I have one too many? 53, I might have added wrong. 10, yeah, 20, 30, there we go. 38, 48, 53. I knew I had the right thing, I just wasn't getting the right total. And then 80, periodic table closer so I could see. Astium 85. Z equals 85. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, and then when you get there, I don't have Wolfbo's diagram in front of me, but I'm looking for it. Then you have to, oh yes, there it is. So then after the 5p6, right, here I go to 6s and then 4f, okay? So 6s2, 4f14, and then after 4f, according to his diagram, then I go to 5d10, and then I go to 6p, and that should be 5. And when I add this up, lo and behold, I get 85. There's another one there that's an unknown, but I think you get the trend. It says, do they have anything in common? Yeah, they all end with the P5, and it's how you know you've gotten to the end. Okay, so that is number 5. Number 6 says, write the full electron configuration for a fluorine ion and a sodium ion. Okay, so we had regular fluorine was Z equals 9, so the fluorine ion is going to be Z equals 10. It's picked one up, so it's going to be 1s2, 2s2, 2p6, 3, oops, sorry, I'm done. Okay, and it ends there, there's 10. And the sodium ion has lost one, so Z equals 10 as well now, and it'll be 1s2, 2s2, 2p6. So from the electron configuration, you can't tell which one's which, and you can't tell that this isn't, it's their neighboring noble gas, neon. Okay? So the electron configuration tells us how many electrons, but it doesn't necessarily tell us what it is, because it could be an ion, or it could be the atom. These are called isoelectronic, meaning they have the same number of electrons, but they're not necessarily the same element. Number 7, identify the element whose atoms have the following. So 1s2, 2s2, my periodic table, has 3 electrons. So now maybe I should add better, has 4 electrons, so it should be beryllium. The next one has 7, and so you count them up, go over, 7 should be nitrogen. I have a tickle in my throat and we're going to run out of time. Next one has 12, and so it should be magnesium, and the last one has 16,